but I want everyone to focus on the structure. So what I'm going to explain you about the block, and then going forward, the same block we will have to start achieving or retrieving those blocks information from the SGF, from the memory. So as you all know, the default block size is 8192 bytes, which is 8 kilobytes in size. Okay. So let's see if I have to start looking into the block. So let's say the user has just created a table, a create table T1, and then some of those, and then table is created. Now when this table is created, a segment is created, right? This segment is going to create one extent, and this extent has 8 blocks. All right. So let's just say these blocks are block A, B, C, D, E, F, G, H. So we have 8 particular blocks in here for one segment. If I start looking into this, basically we are giving a name to this block. And at this point, user executes a query. So I'm going to look into the block A architecture now. So let's say if I say, okay, this is the block A. Now first of all, do you think all blocks are going to be empty blocks? When you have the first table that is being created, you don't have any data, right? So can I say these are all empty blocks? Right? Do you all agree? Yes. So if I have to start looking into the empty blocks, so let's zoom into the block A. Block A is internally divided into 3 different parts. So the first part, the second part, and then the third part. The first part is called the header. The second part, it is called PCT free. PCT free. And then the third part is called the PCT used. Okay, fairly simple. So the header is again divided into 3 different parts. So the first part here, and then the second part here. So the first part here, it is called data block address. The second part here will keep the information about the table. The third part here in the header, it will keep information about the rows inside the table. Okay, so every block has 3 different parts. The header part, the percentage free, PCT stands for percentage free, and then percentage use. Now if I start looking into this, let's say the total size of this particular block is 8192. Then I'm going to remove the header part. Header part, let's just say 192 bytes. So 192 bytes, that will leave me about 8,000 bytes. Do you all agree? I'm trying to keep numbers simple. So out of 8192, the first part is this one. Then I have the second part. Second part is 10%, or by default it is 90%. So this PCT free by default is 10%, and then by default PCT use is 90%. Okay, so that tells me that 10% of 8,000 bytes is equal to 800 bytes. So that leaves me about 7,200 bytes. You all agree? Then from here to here, the space remaining is 7,200. That leaves me 0 bytes available. Do you all agree? Okay. Now, this is Oracle maintained. So basically it's the header part. Oracle is doing whatever the magic it needs to do so that it is writing, keeping track, retrieving the information and all so on. This part here, right? So I have 8000 minus 7200 and then we have the 0 bytes in here. This part here, which is the PCT free, is reserved for future updates only. And then we will look into it. And then this part here is reserved for future or reserved for new data and updated data. So if I'm ever going to add a new row, then this is the part that is going to be utilized. So for example, a user issued this command: insert into T1 and then values and then whatever the values is. Now remember, 8000 bytes in here, right? Out of 8000 bytes, let's say that my first row is about 1000 bytes. Okay. Now obviously when it is going to look at here, in the header, there is something called free list. Okay. When it is keeping track of the inside the data block address, so we have the data block address and then the tables and rows. Basically tables and rows, it is keeping a table, like a spreadsheet called free list. Now free list, if you start looking into this, here it will say block number. So in our case, our block number is, let's say, A. And then it has the table information. So let's just say, what is it called, the row number. So what is the row number that is getting in here? Okay. So total free space. So free space and then free space and then let's say used space. And here we have what is the other one? It keeps track of the percentage. No, I think there is something else that I'm missing. Chris, do you remember what I'm missing here? So let's just look into that. So here insert into T1 values and then it has the 1000 bytes. And then it is also keeping track of that I'm missing. Block status. Okay. So I have 8 different blocks: A, B, C, D, right? And then we have E, F, G, H. So for this particular extent, so far we have only 8 blocks. And can I say all these 8 blocks are part of extent 0? Okay. Now obviously the very first time it has 100% utilized, right? 100%, which are actually, let's say 7200, and used is 0. 7200 used is 0. 7200 used 0. 7200 So block status, do you think block is advertising itself as free? Right? At this point, there is absolutely no information that is being written into the block. So in that case, insert into T1 values, and then you have the 1000 bytes. Now, out of 1000 bytes, the very first thing. Now, this is all part of the same segment. If you guys recall, This is all part of the same segment. Now segment is going to say, hey, okay, hey, segment header, the way we have a block header, we have an extent header, we have a segment header, we have a table space header. Everything has a header that keeps the metadata. So at this point, the segment is going to say, hey, you are the only extent that I have. Do you have any free blocks? So it will look into its header and it says, oh, yeah, I'm looking into the header of extent. Right? Header of extent, which is keeping track of the free list. It says, yeah, it looks like I have all these different blocks which has a lot of space in here. At this point I have like 64 kilobytes, 8 times 8, 64 kilobytes. So out of all of these, there is 1000 bytes that needs to be written. So which block I should be looking at? And it says, immediately it says, the first one that I have is the block A. So if I come back here and it will say, okay, insert into T1 values. Now at this point, block 1 is writing 1000 bytes. Now as soon as this, so now I have the row number 1. So it is keeping track of the space here. So out of these, now do you think this value is getting changed? Because I am saying that free, the use is 1000 now. That makes the free 6200. But is it still going to advertise itself as free? Yes? Do you all agree? Okay. Am I going too fast? Okay. So now the user says, I'm going to insert the second row. When you insert the second row requires, let's say, 1200 bytes. Now for the 1200 bytes, again the same thing. Do you think the A is still available? Right? So now I have the 1200 that is being written in here. Now it comes back in the free list. It says the use is 2000. Now the free is, we have about 5000. Same thing. Now this time user adds one more data, one more row, and then this is about almost 2 kilobytes in size, 2000. So when you do that, now it says, okay, you need 2000. We have about this much space taken. So row 2, this is the row 3rd. So now it will come back and it will say, okay, now the remaining is 3000 and used is 4000. So it is obviously keeping track of all of these. Now the next one that it will say is, instead of insert, it will say delete. Delete T1 where whatever the values. So let's say the third value has to be deleted. Now once the third value has to be deleted, the space is given back to the block. So the third value is gone. So when the third value is gone, 2000 bytes, this is again bumped up to 5000. This is again bumped up to 2000. Right? Was that 4800? No. Is that 42? Or 52? 5200. Right? 70 out of 72. Now if you start looking into these, there is one area that it has not been looked at yet. This is the PCT. This is the area from PCT used. And now I have to start looking into the PCT used, PCT free as well. Because PCT free, if I start looking into this is all completely free. All 800 bytes. So PCT free, 800 here, 800 here, 800 here, another 800, another 800, 800, and then 800. Out of this, no one has used any space. So PCT free, all 800, and then used 0. Right? So now delete this row numbers. So we have deleted about 2000 bytes back to the user. Now this time the guy is saying you insert into T1. Now when you say insert into T1 values, all this, and this time he has added 4000 bytes. Now if I start looking into this, it will say, oh, the A block is still available as free, so I'm taking 4000 bytes from it. So let's say 4000 byte is this much. So row number 3 now is, because that row is deleted, so now we have the second set of the row 3, and this is taken. So the first one was 1200 bytes. The second one was how big was that? 2000. And then the third one we deleted, we added. Now this is another 4000. So we have about 7200 available or completely taken now. Is that right? So now it was saying about 4200 which was available. 4000 was available out of, and then we have 3200 which was used, and then we just added 4000 more. So here let's say it is 0 and then used is 7200. Now as soon as this is no longer used, now do you think the block status will change to free to busy, or do you think we still have the PCT free here, so it is still going to advertise itself as free?
It's not free. It's not free.
Why not? Because I still have 800 bytes available in this area. So it is completely full with 3 or 4 rows. I understand that part. So PCT use is full. But why the block is not going to advertise itself as free when you have about 10% space which is still kept? Because it is reserved for updates only.
Future only.
So if I'm using any of the update command, then I can use this, but inserting a new row, you cannot do that. Yes, you're asking something? Right? So at this point, it will say, no, I'm no longer available, so I'm going to change the status to dirty block. It means I'm no longer available. The block status has been dirtied, so I cannot use it. It's all full. All right, fine. So now the user says, I want to add a new row now. So let's say insert into T1 values, and then some values. This time the values is 2200 bytes. What do you think will happen now? Which block it is going to target? Block B. All right. So here, let's look into the block B now. So block B, we have the same structure. We have the header. And then we have the PCT free. So we have the header, PCT free, and then we have PCT used. PCT header, if it is taking 192 bytes, this one is 800 bytes, and then this one is 7200 bytes that are available. All right, so row number 4 now. So I have the first row, I have the second row, then the third row is deleted, third row is created, and then I have the fourth row now. Fourth row requires 2200 bytes. Obviously it is going to look into the free list here, and it will say which one has the 7200 bytes available, or at least 2200 bytes. No, this one does not have 2200 bytes available. Does this one has free 2200 bytes? Yes, it does. So it is going to go, so for row number 4. Now the header has the data block address, right? And then it has the table segment information and also on, and then it also has the row. Now when you look into the rows part here, do you think we have, if I'm looking into the header, it says I have the row 1, I have the row 2, and then I also have the row 3, right? So this one will say, okay, I have row number 4 now. Where is the points to? So row number 4, it says 2200 bytes. This is row number 4. So this pointer is pointing to this data internally. Similarly, when the connection that comes from outside, and if it is reading the block is not scanning every single block. It is saying, do I have this table? Yes. Do I have these rows? Let's look at it. Which row do you want? I want row number 3. So row number 3, it will say, okay, I have a pointer pointing to this, and that's how it is reading it. If you're saying where equal to this, and that happens to be row number 2, row number 2 will say, okay, I have a pointer pointing to this. If it says where equal to this, and it happens to be row number 1, then the row number 1 has a pointer pointing to row number 1. That's how it is fetching the data. So If you say select star, that means read everything. So it is not just pointing and scanning, it is basically dumping everything from here to the memory to the user. So here, let's change this again. Free is 5,000, right? And then this one is 2,200. Now I'm going to add one more data now, row number 5. Row number 5, insert into this, we have another 2,200 bytes. Now which block it is going to look into? Block A, block B, or block C? Block B again, because I still have 2,200 or 5,000 free here. So here it will say, okay, row number 5, I'm going to have it row number 5 here. This is row number 4, pointer, and then row number 5, 2,200 available, 2,200 again is being utilized. So now this one is reduced down to, this is 4,400, and was at 5,000 is reduced to 2,800, right? So free block, free list is all this doing. Now row number 5. Now row number 6, or not row number 6, but for let's say row number 2 is now delete, blah blah blah. So row number 2 is going to release 1,200 bytes. Now where is row number 2 hosted?
Block A.
Block A. So now can I say this space has been freed? Now as soon as this is free, that means I have 2,200 bytes or 1,200 bytes available here, and then I have used is 6,000. Now is it immediately going to change itself as free now?
Yep.
Because it has some space. Now it may not have enough space for all the rows, but it has 11 or 1,200 available. So far okay? Now row number 5, we are going to go with row number 6. Now row number 6, insert into T1, and then this has 600 bytes only. Now which block do you think it is going to use now?
Block A.
Block A. Why? Because block A has about 1,200 available. So immediately it will say, okay, I'm going to use here. So row number 2 was removed, remember?
Yep.
So the pointer is no longer available. It is updating. So now if I add one more in here, so row number 2, so 600 bytes. This is 4, insert into T1, and then this will be row number 6 now. Row number 2 is gone now. Row number 6, 600 bytes. Again, it is going to perform some calculation. It will say, I have 600 free, and I have 6,600 used. Is it still advertising itself as free?
Yes.
But free for only 600 bytes, right? This one is free for only 2,800 bytes. If you require more than that, then it will obviously go into the third block. So let's say row number 7 now. Insert into. And then this requires 4,000 bytes. Now block A, is it 4,000? No.
No.
Block B, 4,000 available? No. So block C.
Yep.
So we are still part of the same segment, right? Obviously it's all the same segment. We're still part of the same extent, right? So this one is has free 600 bytes. This one has 2,800 bytes. This one, block C, has 7,200 bytes. So obviously it is going to the block C now. So here I'm going to come up with block C. Now block C has the header part, and then it also has the PSCT free and PCT use. So PC, this is the header, PCT used, sorry, PCT free and PCT used, and this is block C. Are we okay so far? Okay. Now at this point, and then we are using 4,000 bytes. So 4,000 bytes is occupied by which row? Is that row number 7? So 4,000 bytes. So we have all this data that has been used in here. Okay. Now this is still free. Now at this point, I have update row 1. Now remember, row 1 is 1200 bytes, right? Now from 1200, we like to go to 2200. And the user says commit. So which area, let's say from 1200, we'll go to 1500 bytes. So basically add 300 more. Which area do you think it is going to use? Is it going to use this area, which is free? Is it going to use this area, or is it going to move to a different block or combination of all this?
PTC free. PTC free.
Sorry?
PTC free area.
Well, this one is still 600 free, which is still this. This one has 600 free bytes available, right? You still have 600 bytes available. So this particular row requires 300 more bytes. So don't you think it is going to use 300 from here somewhere? So this area plus all this is part of the same block. Right? Don't you think? So here it is just going to say, I still have the same pointer. This pointer says, okay, part of this and then free space here, combined together, we have this area. So the data remains in the same block. So now this one has been reduced to 300. Now have we used any space from the PCT free? No. And then now at this point, we will have update on the same row. Update row 1. Now this time from 1500, last time we updated to 1500, right? From 1500, upgrade to 2100. Now 2100, what's the difference now? 600 bytes it will have to add to it. So if I start looking into this area has how many bytes? 300. And then where exactly is the other 300 is going to come from? PCT free, because this is reserved for the updates only. So if there is an update that requires more space, then this space will be utilized. So it will occupy 300 as part of the same block, right? And then it will say come back here, and then I'm going to use 300 from here. That leaves me about 500 space available. So here it will come back and it will say free, absolutely nothing. Use all 7200. And then out of this PCT area, it is 500, and use here is 300. Does this make sense? So far, are you okay? And this block, is it going to advertise itself as free anymore? No. So this is dirty block now. Will not be available unless and until something is free in this area, not in this area. Right? Now at this point, row number 10. So let's do an update here, and we will say I'm going to use update row 1 again. This time from 2100 to 2400. Now if I go with the 2400, what do you think will happen? Do I still have 500 available here? What is the difference I need? 300 more? So it is going to add 300 more here. That leaves me a space of 200, which is still advertising as free. So here, we'll come back here and we say,
No, it's 0.
Is that 0 now?
Yeah, because you used 300.
No, PCT free, no, it is not 0.
Oh, it's 500?
500.
Oh, okay.
Right? Used was 300, so that leaves the 500 space free. Out of that 500, I'm using 300 more. So used is 600 now, and then PCT free is still 200. Does it make sense? Any questions so far before it actually getting a little trickier? Yes.
This is all DML, right? What about the DDL?
Sorry?
This is all DML. What about the DDL?
This is all DML. What do you think about the DDL? What is a DDL? Give me an example.
Well, it's basically the header, right?
No, DDL is when you are creating something, when you are dropping something. So when my DDL has already been executed. That's why we have when you say create table, this is a DDL. So it creates one segment, it has one extent. If I start zooming in, so I have one segment, one extent, and 8 blocks. That's how it is happening. Now one of the DDL at this point can happen is drop. If I drop, everything is gone now. This is space is back to the my table space. Any questions with this so far? No. So far this is the architecture that we are looking into. Okay. Now at this point we have row number 11 again. So now we have execution number 11. Execution number 11, again there is an update on row 1. Now it is going from 2400 to 2600. Right? Now that will still utilize this complete space. So now I have 200 added here. So I have all this space as part of the same block now. So at this point, percentage here is 0 and used, again change it to 800. Are we all okay so far? So if I start looking into this, how big is the row number 1 now? Row number 1, 1200, plus it occupied
300, 300.
was that 600?
Yeah. 300 and 300.
No, 1200 bytes and then insert into T.
600
This is 600
plus 200.
plus then I
Plus five,
said
plus 300.
insert into this and then 4000. No, wait. Okay, I'm lost now. So 1200 here and then 300 and then I think we added another 600, right?
300.
Okay, let's just say this is what we have now. So we added 300 more, then we added 300 more, then we have 200 more. So if I start looking into this, row number 1 is 1824, 3200 now. Is that right? Now, 3200 and then, is that 3200?
No, there is 6.
Is it still
Only
26?
600 only.
Sorry?
Only 600 once only. One time only 600. There left. Where you added the calculation.
Okay, let's just say the current row size of this is 3200. Okay, so now, right now, if I start looking into this, row number 1, current size is 3200. Okay, so 3200, if I start looking into all of these, this area, row number 1, so I'm going to have row number 2. And then row number 1 is close to about, I have 800 that is being utilized here. So this 800 and 2400 here. 2400 and 800 here. This is all part of row number 1 now. Does that make sense? So 2400 from here and 800 from here. Right now the total size is 3200. So row number 3200 from here, it wants to grow to 5200. Right? So the same row got an update now, and it is going, and the more update, that means there is new data in different columns or same column. From 3200 we need 2000 more bytes now. If I start looking into this, 2000 more bytes, I don't have 2000 free bytes available here, do I?
No.
Okay, so how can I expand something? Now the second row, that the closest block is this one. If I start looking into this, I may have 2800 available here, right?
Yes.
Free is still 2800. So what do you think will happen now? Multiple options here. First option is, how about if I keep the 3200 here and then add plus 2000 more, so I can keep, so block A can keep 3200 and then block B can keep 2000, right? So this will still be considered as row 1. But the problem with that is, think about this. If you have two office buildings, office building A, office building B, and if I'm saying, my boss is saying, hey, can you go get certain files from here and go get certain files from there. So I went to that building A. Building A says, oh, I have half of the files here, but to get the other half, you have to go to the other building and get it. So do you think is it taking me longer now? Because I have to fetch the data from building A, go back, take elevator, come back, and then go to the other building, take elevator again, go back, go up there, bring the data back. So my trip has cost me twice now. Instead of that, if I say, if I cannot keep all the data in building A, instead of keeping half data here and half data there, if building A is running out of space, why don't we move all the data to building B? That way, the next time I go, I shouldn't go to building A and go to the building B and then find out this. So instead of that, I will just go to building B, get all the data. So can I say I will migrate my data from building A to building B to make it much more faster? Yes? You were saying something?
Can we not just expand the size for A?
No. Once the table segment is created, it's created. Okay, there are different ways I'm going to show you later on, but without that having any downtime, we cannot expand it. So which option is better for me? Keeping the data separated into two buildings or migrate from one building to another building?
So move it to another building.
Move to another one, right? So that's exactly what the Oracle does. Oracle will say, okay, I'm going to take 3200 from here, and then you want to add 2000 here available. So what that means is, if I have to migrate row, first thing is find which block has 5200 available.
Yes.
Has 5200 free space available. So in our case, if I start looking into this here, which one has the 5200 available? Block C. So now we will come into the picture. Now if I start looking into block C, no, block C actually has 4000 here, right? So I don't think we updated this.
Oh, we do.
So use was 4000
3,200.
and this one is 3200. Right? So block C is not really a good candidate. So in that case, I will have to migrate this. So we have the header, we have the free space reserved, and then this is block D. Block D, if I start looking into this, row number 1 has to be migrated. So when I'm migrating, I have to migrate the complete thing 5200, right? So it will say, okay, you have 5200 available here. So row 1 has been moved here with 5200 available. Now if it is 5200 available, earlier 3200, do you think this will have to be freed now?
Yes.
Right, the entire data has been blocked, moved. So now I have this. So I have 50, how much was that?
2400.
2400 is free now. And this one is again free, 800 free. Now if I have 3200 available here, that means, so free is 3200 and use is, no, this should be 2400, right? Because 800 is given back here, used is 0, and used here is 32. So total, no, used is 2400. Right, so we got this. Used is, how much is that? 4800. So it is doing all this calculation internally. And since it was marked as a dirty block, it is going to mark itself as a free block again. But the problem with this concept is, first of all, do you think this is a good concept? At least getting partial data from here, partial data from here is still a problem, right? Getting half from here, half, so 2 seconds here, 2 seconds here makes 4 seconds. If I keep migrate everything, it will be getting, I can get the same thing in 2 seconds instead of 4 seconds. So I'm actually reducing half of it. But the problem with this is, Oracle has the engineering built. When they came up with this structure a long time ago, their data wasn't that big. So what they said was, when you create a table, when you add a row, you are basically giving a unique identifier to that row. Okay, it's like a social security number for the row. So whenever I'm adding a new row, so for example, row number 1, right? Row number 1 has put a track in here saying that I have the social security number assigned here. So this row number 1 will never move now. So every time I'm asking something, it will always come to this particular block only, and this block will say, hey, you know what, row number 1, if you are ever looking for row number 1, go to block D. Was that C or D? Block D. So your sessions is still going to hit the same block. Same block will say, okay, let me find if I have the row number. If maybe I have partial information or whatever it is, I'm going to find out. So it will talk to the header. Header will say, if somebody is looking for row number 1, they have to go to the block D. So the connection is coming to row block A first, and then from there it is pointing to the block D. Because the row number is a unique identifier, and then the unique identifier actually has the block ID as part of the unique identifier. So it cannot be changed immediately now. So the block ID, because it is looking at the block ID, it is always hitting the first block that it was ever hosted, and that block is going to send it to somewhere else. Now let's say I have the same thing now. I'm going to add, so transaction 12 now. So this time we are going to say insert into T1, and then we have this. That will actually, so block D has 3200, block D, so we have to update this one. So it is taking 52, and we have 2000 available here. So now I have insert into T1, and then which row are we at now? 4, 5, 7. So let's say this is the row number 8. Row number 8 requires 2000 bytes available, right? So if that is the case, that means this entire space has been occupied now for row number 8. Is that right? So if I come back in here, this one used is 7200, free is 0, so that makes this one as a dirty block. I haven't used space this big, right? Now if I say go back and update row number 1 now, update, so this is 30, update row 1, increase the size from 52 to 57. What do you think will happen now? 5200 bytes to 5700 bytes. So is it going to go to the block E, or is it going to use the space that is available here? So basically it will say, okay, I'm going to use the space available here, right? And then we will maybe leave about 100 bytes available. So here it is going to come back and it will say we have 100 bytes available, and then we have 700 bytes used in here. So far are we okay? Okay. Now we are going to have another update on the same row. Update row 1. This time, last time it was bumped to 5700. This time we have to get to the 6000 bytes. So about 300 more bytes. So 5200 was taken from here. Even if I and then added this 700. So right now this particular row is 5200 plus 700. Right? Was that 700?
Yes.
Yes.
No, 500.
It's 200 left.
Was that
It's 200 left. Yeah.
okay? So the free was 300, and this one was 500, right? So I have to update the same thing in here. This is available 300, and this one is 500. All right. So at this point, we are saying update row 1 from 5700 to 6000, or let's say 6200. So from 6200. Now is it going to, so that means I have the difference of, delta is, I have the difference of 500. So where is it going to get the 500 bytes now? It only has the 300 available.
Next it goes to the default.
So what that means is now I have to, the row has already been migrated once. So does that mean the row has to migrate again now? Yes. Because otherwise I don't have enough space. So here it will say, okay, the next available that I have available is block E. Now if I have block E, again, this is 800 bytes, this is 7200 bytes, this is the header. So this entire row has to be migrated because now the 6200 bytes. So out of 7200, 6200 is already being taken. For which block, which row?
Row 1.
Row number 1. What that means now is this space has to be freed, right? So now how much was that space?
500 plus.
57.
So 800 here, and then this space, how much was that? 52? Okay. So this space is back now, so again it will come back to D. D says how much space? PCT free is 5200, right? And then the used is 2000, and this one is again back to 800. This one is 0, and this one is going to advertise itself as free again. However, if I start coming back into it, remember how row number block, so the initial, it is sending to block A. Block A has a pointer to block D. Now block D has a pointer to block E now. So can I say the more times the data is migrating from one block to another block, the more pointers that you have now? So this is same thing as you going to block A. Block A, reception is saying, hey, whatever the file that you're looking for is no longer hosted here, go to building B. And when you go to building B, reception is there saying, hey, building B used to host this, we don't no longer use it, we no longer hosting it, go to building E now. Right? So here, just because the data has been migrated, the very first time, if I'm getting this in 1 millisecond, now this one is added another 1 millisecond here, and then this one is added another 1 second. So initially when the same data when I was getting long time ago, it was costing me 1 millisecond. Over the time, it is taking about 10 milliseconds now. The reason is, and sometimes this, in fact, a lot of time this happens, when you have a laptop which is, the very first time it is very fast, and all of a sudden you start using it, and then it will start slowing down, right? So the blocks internally in your hard drive also move. They use similar concept. Databases also use the similar concept. So the more that the data has been moved from one block to another block, the more fragmentation is happening, the more reorganization, it will start taking more time. It will have to start working on this. The more it is free, the more calculation fast it can be done. The more it is doing all this, then there are more internal latches. Those are called internal locks. Locks are in technical terms, in here called latches. So latches are start fighting, hey, I need to do this, I need to do this. A lot of updates are happening. Now this is only if you have one block, one extent, right? It is a very small table. Now imagine if you have 200 extents. Imagine you have 400 extents. Imagine your table size is, just one table size is 300 gig in size. Can you imagine how hard it is for it to maintain the free list? The more updates that are happening, the more it has to not just update the block, not just move the blocks, not just keeping track of all the pointers, it has to keep track of the free list as well. So the more slower the database is getting. So if I have a choice, so this is called row migration. This is another interview question. What is the difference between a row migration and then row chaining? We haven't talked about row chaining yet. But how do you describe row migration? This is a very famous interview question. What is row migration? Row migration is when a row is migrated to another block. Very simple. So here I'm saying block A, the row has been migrated to block B. from block B, the row has been migrated to block E. So my initial connection is still coming here. This session is saying, oh, I have to send it to you. And then this guy is saying, oh, I have to send it to you. The more that you have now, the more, the bigger, the fatter the table is, the more free space, the more fragmentation. So now you can have multiple lookups. So each lookup is adding some time. And then finally, the contents of the block, row 1, is found here. But each of this, the first time it was only 1 millisecond. The second time, millisecond. So the third time, millisecond here. We have 1 millisecond, 1, 1, 1, 1, 1 millisecond, and 1 millisecond. So here, if I start this in January, I was getting everything. My customer was very happy. I was getting everything in 1 millisecond. February, they are still happy, no problem, right? March, they're like, what is happening, man, right? And then the more of these that is happening, so now I have 4 millisecond, 5, 6, 7 millisecond, 8 millisecond, 9 millisecond, and then finally, by the time when they are in holidays in October, it is taking 10 millisecond. I don't know if they are sad. I don't know how to draw the Gussa wala face, but I think that's how the guy is going to look like. He's very mad now. 10 milliseconds. Just because the data is keep growing does not mean that performance has to slow down. How do we tackle this kind of a problem?
Can you assign
Kinjal, are you busy?
We assign bigger
Can you assign one row to each block?
Sorry?
Assign one row to one block.
So what you're saying is, even if I have so this is the block size, right? So even if I have one row, which is 1 or 10 kilobyte, I'm going to reserve that space for the entire 8 kilobyte block. Sorry, not 10 kilobyte, but 10 bytes.
You're gonna waste memory, but waste.
We are going to waste a lot of space in doing so. So let me tell you this. How about
Increase.
if we go with a design where we are going to say, I'm going to keep PCT free as 60% and PCT used as 40%. That means I'm only allowing limited data here, and then all this limited data have free enough space, so instead of going into separate blocks, it can just play around in the same block. If I'm keeping 90%, that means I'm allowing, so think about this, look at the difference between these two. If I'm keeping the 90%, and that means I have 1 row, 2 row, 3rd, 4th, 5th, 6th, 7th. I have these many rows now. So I'm only keeping the data for 1 row to update. Every time the other rows need update, they have no other choice but to move to the other blocks now. So what if I go with the PCT free with a bigger value? So I have sometimes seen 20% and 80%. I have sometimes seen 60% here and then 40% here. I have seen where there are lots and lots of DML. It's a data warehouse, for example. There are always constantly being written. A lot of times it is updates. You know, you will only create the record once, but majority of the time it is updating. So in that case, I would probably go with 80% here and 10% here, or 20% here. So if I do that, then I'm only restricting. I'm only keeping 2 or 3 rows in here, and I'm leaving this much space for future updates. So even if it needs more space, it is still going to play around in the same block instead of the row migration that is happening. Don't you think? But the problem with this is you have lots and lots of free space. If one table is not being updated that much, it doesn't make sense for me to go with this design. For example, think about these 2 tables. Here, I will say which table should have what kind of design? How many times do you think we are actually going to change a table called states?
Few times.
Right? Maybe a couple times in a century. So the chances are this table is going to remain static. If I keep the table as a static, what that means is PCT free 10% and PCT used as 90% makes sense. Because we are only keeping this much space for future updates and I'm occupying the entire space for the data. Whereas if I go with the stock price, what kind of, do you think the stock prices change every seconds now? Right? So there is one company logo for company name, for example, Microsoft. So the company name is not going to change. So the rows are probably not going to change, but it's the constant new data and then the existing data will keep changing. So in that case, this is more of a dynamic table. Lots of updates. If I go with lots of updates, it probably makes sense for me to have something like this.
60%.
So this is PCT used. I'm going to go with 30% and PCT free, I'm going to keep 70%. So whatever the 30% rows here, they have lots and lots of space to play around in the same block, and then we are avoiding the row migration. What do you all think? Do you think this is probably a good design? But this is good only at what time? When you initially design the application. Right? This is only good when you initially design the application. But once the application has already been designed, it has designed with something like this. When you are actually operating something like this, you're always going to have performance problem. What do you think in this case? What do you think we can do? First of all, let's say you are a developer. You're designing an application. And you are designing an application for postal, USPS. So I would probably design something like this. Right? PCT used here, PCT free here. Versus if you are a developer and you are designing a table which is going to have a lot of dynamic changes, I will probably go with this one. But long time ago, when there was no teacher called Mohit, people has actually designed a table like this or like this when it should be the reverse of each other. So the application has already been created 15 years ago. Now application always has performance problem, and then as a good DBA you went there and you identified this problem because you have a lot of row migration. So in that case, you cannot change the existing design of the application. It has already been created. What do you think we can do now? In this case, we will require a small downtime. So case, lots of row migration has been identified. Okay, on table T1. Size of T1 has 100 blocks, for example. Okay. So 100 blocks of this, and majority of this are row migration that is happening. So what can I do? How to fix this row migration problem? First thing what we are going to do is need a downtime. So now at 12 o'clock, shut down database. Right? Once we shut down database, what we'll say is create table T2, right? And then we will say where T2 as select start from T1, but if you execute right here, it will be the same design, PCT free and PCT used. Here I'm going to say PCT free is 70% and PCT used 30%. So now do we have a T2 created with this new settings? It has all this new data, yes? At this time, we will say drop T1 table, then rename T2 to T1. And then once everything is done, then start up database. Now when the application is going to point, application was earlier pointing to this, now it is going to point to this. But when I check the size of the table now, remember when we did this, the size of the table was about 100 blocks, right? When I check it now, size of T2 is probably about 700 blocks. Because majority of that, 70% of that space is just free. So if you go with a design like this, increase the table by so many percentage, right? Whatever that you are keeping it like that, the table will grow with that big of a margin because you are leaving more space, but this will definitely bring the performance back to your database. So the more updates that are happening, it is never looking for a new block. It is always constantly cycling into the same block. If it requires more space, it will get that from free, PCT free. If it is deleted, any row is deleted, it will still delete from the same block instead of row migration. So let's take 5 to 10 minutes of your time, and I want you to write down each of these before we step into the next thing.
I mean, I can take your pictures and post them in the group. Yeah. The small one. Yeah, because her birthday is it was the 17th. Like art craft? No, just ceramic figurines. Like that. So they're going to get fired. I'll show you here.
For burner?
Yeah, they burn the ceramic. You know, no, you know, like
Put it back?
in the kiln, they fire them. They fire them to melt. Were they gonna melt it or they're gonna harden it? They'll glaze clay at UV. Like and then they fire like that. No, fire. And then you could eat oh yeah, I remember doing that. Yeah.
The flame?
The flame and yeah, I think so. But the adult will do it. The kids just eat. Like they get to pick up things, figurine or jewelry.
It's a nice kids go to the shop, they go to the shop and they play and catch it. They do a lot of fun. And what Keegan is good is so much good.
Let's go here and jump in. Have you guys ever been? Okay, this fall, come here to this Jamaican farm. It's really nice. It's shade, but it's fun because they have the puppy in the bag, they have baby chicks, like so many. Yeah, we went to one. What is it called? Yeah.
Or by
But yeah, so how is so
Pay more money.
I just want to take him to like a farm and let him have the farm.
Okay, first
It's only like 2, and he's home with me. It's only his cousin.
Pay more money to go harvest yourself, pick up apples and then buy it from the shop. They have the shop in the back. I have those bags, like paper bags.
Really? I never thought about that. You can take your bag and just throw it in the truck. They had a lot, and then you go there. So much gets wasted. My son was just like, that's
I
how he
stole some
drank.
pasta.
Yeah, he loved
It's the juiciest honey.
Jonathan.
It's not, yeah, nice north from that. All the way from Chicago, maybe more. Yeah. What has? On this? No worry, it starts to come up. Hey, it starts to come up from here, so.
But this is easier. I tried to find the time.
Good. The other way, left.
Can't get it.
Better.
I can't.
Got it.
I can do my own
Like 5 of them we did it from 25 to now.
Oh yeah. The whole printer, the faster.
I have like 5, 6 hours. Like,
Like the last 5 questions. I don't wanna. No, I don't want to because then you don't.
oh, the guy.
Honestly, yeah.
This from the nose.
Because I looked at it, the last 5. This is like the C reference.
I don't know. It's very complicated.
Because you have to look through the notes. Yeah. Like I looked like he said, can you shrink?
Hey guys, let's take a quick 5 to 10 minutes break and then we come back. And then I'm going to, we will end class today at 2:30. Okay, so we don't have that much. I can give you 60 minutes back to you. Oh, look at all your faces, man. Everyone is so excited. All right, so let's take maybe 5 to 7 minutes of break and then we come back.
Can you also attach your mouse? I get really sleepy. It will fit her. When I came
Only one maybe.
So I got tired. Take care.
شيكاغو سوق دارت صاحبي ساكن في روميو ما عرفش شحال هذيك السياحه راس معايا في لافا صارت عرفت على عمري ما عرفت في شيكاغو في شيكاغو السيرفيس ديالتي كان لي طوموبيل $1000 الشهر دير بها بكثر خدمه اوبر في شيكاغو لا ولاتها الشهر كامل
The cake is already لا ما عمرنا حد نسمع الناس لا كيش كل لا حالة أنا مشتري بيع لكم مسلم
نعطيك الضوء ما عنديش مشكل هي مزوله ما بقاش كيشربوا في الروم ديالها المريض راه مريح ديالو يمشي عند الثاني عندك زوج
He's a bit very aggressive. He's not aggressive.
ليش ما تحب الأراجيل؟ ليش ما تحب الأراجيل؟ ليش ما تحب الأراجيل؟ أنا بنسمع بينات
حكيت البارح حكيت المغربي وبيضحك
مولد أنا بدي بدين
والدينا دار البيضاء.
Okay guys, so what I'm going to do is I'm going to create a user or create a table space. Okay, so create table space static TBS identified by or data file 14 or our data, which database I'm going to work on. Batch 40? Okay. I think batch 40 is
Or 39 last time.
sure. Can you rebuild batch 40? Actually, I think the script is already there. I just have to. Okay, so let me do this. Shut down a port. Okay, let me just recreate it. So it's base, CD admin, batch 40 scripts. All right, so okay, while this is happening, I'm going to say create table space static TBS data file batch 40, and then static TBS 01.tbs, and I'll say size 25 M. Auto extend on, next 25 M, and then max size unlimited. Okay, and then identified by this, default table space is static TBS. Static user, and then we'll say create table static user.t1 as the select star from db underscore objects. Then we will also say I'm going to double this one two times. Insert into static user dot p1 select star from static user dot t1. Okay, I'm going to double this twice, and we will say commit, and we will say select counter star from t1 or static user dot t1. And then, all right, so let's do this. Is the database up yet? No, still reading. That's fine. Now, while this is happening, let me just start another database. I had like MMDB. Okay, so in my database, wherever batch 40, I have to replace that with. Okay, so I'm going to create my first table or my table space here. Can we shut down some other databases? Speed this up, please. So my table spaces are so I'm going to create my table space. All right, so I'm going to create my user now. And we will find out which user, so column called username format A10, column default underscore table space format A16, and then we'll say select username, what date it was created, account status, default table space from db underscore users, where username in, right now I only have static user. Right, so I'm going to grant this before I actually do that. So grant all this. And then let's find out the details about this user. Okay, so it looks like the username is this, created on this date, account status is open, and then the default table space is this much. Are you all with me so far? Yes?
Yes.
All right. I'm going to create a very small table, and then this table has the default. I'm not changing anything like PCT use, PCT free, nothing is changed. So I'm just using the default. Basically what this means is, if I execute this here, what this means is PCT free is 10% and PCT used is 90%. That's what it means if I'm just executing it here, right? But how can we verify if that's actually the truth? So I'm going to execute this. So it is going to create my first object. Okay. So here we can use describe db underscore tables, and then we can pick, so column owner format A10, column table underscore name format A20. Alright, so let me do that. Table is created, so I'm going to use describe tables. If I do that, it looks like there are a bunch of things I can use. I can select the owner, table name, table space name. So here let me add that as well. Column table space name format A20. And then if you look into here, PCT used and PCT free. So I'm going to check into the PCT free now. So column PCT, oh, these are the numbers, so I don't have to define this. So I'm going to say select owner, comma table underscore name, and then table space underscore name, PCT free, and PCT used from db underscore tables, where owner equal to static user. Alright, so let's run this. Okay. So we have owner static user, table name T1, table space name is this, PCT free, which is 10%, that makes the PCT used as the 90%. Now let's check into the size of that particular table. Okay. So here I'm going to come back in here. And let's check the size. So owner segment, and then owner equal to static user. All right. So for this, how many number of rows that we have? For number of rows,
Select the columns.
so I'm just going to, before I do this, if I say select count star, so we have 73,298 rows, is 27 extents, and then 12 megabytes in size, and 1536 blocks. Now if I go with this one, so think about this. We created a new user called user is static user, and static user has a table called T1. T1 has 1536 blocks, 27 extents, and total size of this particular block is 12 megabyte. Now this is all for how many rows? 73,298. Do you all agree?
Yes.
Okay. All right. So this is the default one. I'm going to create a new table. Create a. This time I'm going to, instead of using the static, I'm going to use dynamic. Alright, so I'm going to create a new table space called dynamic TBS. Okay, and then create a new user, assign all that, and then the default table space. Let's try this. So we have a dynamic user now. We had a static user earlier. And here I'm going to create a new table. But this time, what I'm going to do is, I will just say PCT free 70. So look into this. Create table this as this. And here I'm going to say, when you are creating the table, PCT free and PCT used 30. Okay. So the reason why we are doing this is because why? Because we want to reserve more space for the future updates. If with this table, the design is like this. For each block, we have the header, and we are leaving 10% of space, and this is mostly PCT used. So this is where all the rows are going to go, and then this is the free space for future updates, and this is my T1 table. Okay, so far? All right. This time we are going to create another T1 table, but the T1 table for a static. So this is a user called static user. So here we are going to have a user called dynamic user. Dynamic user is going to have T1 table. T1 table is going to have a very similar, but for the number of rows. Number of rows we are going to have is 73,298. I think with this new extension, I think we are going to have 299. So let me try this. So create table this, but this time PCT is 70 and PCT use is going to be 30. Now, do you think the table size is going to be very big now?
Yes.
I guess so, because the design that we are looking for is, if this is the block, if I have the header here, then 70% and then PCT free is only 30%. Whereas here, the PCT use was at 90% and then the free space was this. Now can I say this entire space is reserved for updates? So obviously that it can fit, this one can fit a lot of rows. If this can fit 10 rows, right? And here we can fit about 3 rows. So obviously the table size is going to be very big now. And we can test this in a minute now. So we have 70%, that means this is 30%. Now I'm going to count objects. 73,299, and here, if you look into this, okay, so 3 times more now. So here, if I start looking into this, total 50 extents. Same amount of data, right? We didn't change anything. I used the same code. So 50 extents now, that means it has reserved more space for future updates. So that was 12 megabyte, so it's actually 3 times or almost 4 times more now for the same amount of data. And then total size is about 35 megabyte, and number of blocks, we have 4,480. If you compare that with this one and this one. That one has 1536 blocks, this is 4,448 blocks. That one was 12 megabytes, this one is 35 megabytes, and then that one has 27 extents, and this one has 50 extents. Now, not only that, I'm going to double this. Let's see how it behaves when I double this. So we'll execute the static command here. And I'm going to go with another static command and then the dynamic command here. For this one, we have this. For this one, we have this. I'm going to double this now. Insert into static user dot t1. Select start from static user dot t1. Okay, we do the same thing here. Insert into dynamic user dot t1. Select start from dynamic user dot t1. Okay, so I'm basically I'm doubling this, and let's find out what is the size now. So I'm going to execute this 38, and I basically have to commit as well. I'm just waiting for this commit to complete. All right, so let's look into this. So the static user has 61 blocks. Dynamic user has 89 blocks. Do we have the same amount of data? Which I doubt, but I'm going to test it. Select count star from static t1 static user dot t1. Select count star from dynamic user dot t1. Yeah, same amount of data. Look at the size. You have 61 extents, you have 89 extents here. You have 46 megabyte in size, and this is 144 megabytes in size. Right, 3 times more. And then this is these many blocks, and it has 184,000 blocks or 18,000 blocks. So same amount of data, but because we are keeping bigger size. Now, if I have a static data that is never going to change, I'm going to go with a design like this so that I'm using maximum space possible. If I have dynamic data where it is constantly going to change, to avoid the row migration, we are going to go with this one. Does that make sense? And to create the table, we simply have the way we are creating the table is we are just adding. Where did that go? Yeah. Look at this. If you do not give, if you just say, oh, I'm going to create a table based on this, this will automatically be 10, and then this will automatically be 90. Now, if I know that I'm going to have a lot of updates in a table, then I'm going to definitely have something like this. And where can I get all this information from? db underscore tables. Will tell me all of these. Does that make sense? Okay. So at this time, I'm just going to stop our class here today. I'm going to share my notepads with you, and inshallah, I will see you all tomorrow.